The Code Behind the Curtain. Stephen Wolfram, Tom Campbell, and the Ancient Concept of Akasha by AZLAN ADNAN, M.A. Saturday, 27th of December, 2025. Stephen Wolfram and the Computational Universe. Stephen Wolfram is a name synonymous with computation, mathematics, and the quest to understand the fundamental structure of reality. He is widely recognized for creating Mathematica, a computational platform that transformed mathematical research and practice, and Wolfram Alpha, a knowledge engine that allows humans to query vast datasets and extract patterns with unprecedented efficiency. Yet Wolfram's intellectual contributions extend far beyond these tools. Perhaps his most radical work is encapsulated in his 2002 book, A New Kind of Science, in which he argues that the apparent complexity of the natural world can emerge from the repeated application of extremely simple computational rules. Wolfram demonstrates this principle using examples like Conway's game of life, a simple grid-based cellular automaton, to illustrate how intricate patterns can arise from minimal rules. More strikingly, he explores elementary cellular automata, such as Rule 30 and Rule 110, where straightforward binary rules iterated over time generate outcomes that are computationally irreducible, behavior that appears random, chaotic, or complex without any explicit design. Through these examples, Wolfram challenges the conventional belief that complexity requires complex causes. His insight is that iteration alone can produce phenomena resembling the turbulence of fluids, the branching of neurons, or even the distribution of galaxies in the universe. Central to his later thinking, particularly in his 2019 physics project, is the concept of rulal space. This term describes the totality of all possible computational rules, and by extension, every universe that could emerge from them. In this framework, the laws of physics governing our universe are not uniquely chosen or imbued with intentional design. They are merely one corridor in a vast mansion of possibilities. Our universe appears elegant not because it was deliberately crafted, but because it is the corridor in which observers such as ourselves can exist. In Wolfram's model, all events unfold as a hypergraph, a network of nodes connected by edges, that updates itself, step by step. Space emerges from the relational structure of nodes, while time functions as the counter tracking the evolution of the graph. Particles appear as persistent knots in this evolving network, and gravity manifests as curvature in the hypergraph itself. There is no overarching architect, no blueprint, and no intrinsic meaning. Computation alone drives the unfolding of reality. Matter is mostly empty, but not nothing. Modern physics confirms an astonishing paradox. Matter, the very substance of the universe, is overwhelmingly empty. Atoms consist of tiny, dense nuclei surrounded by electron clouds that occupy a volume millions of times larger than the nucleus itself. The vast majority of the atom is empty space. If all the empty space inside the bodies of every human on Earth were removed, all of humanity could fit inside an apple seed. Yet this emptiness is far from inert. Quantum fields fluctuate constantly, and virtual particles spontaneously appear and vanish. Energy never reaches zero, even in the vacuum. Ancient traditions recognize this dynamic void with the concept of Akasha, a Sanskrit term meaning sky or ether, understood as the subtle medium carrying vibration, information, and consciousness. Philosophers and mystics have described Akasha as the repository of all experience and memory, a cosmic substrate underlying physical phenomena. While these ancient frameworks are poetic and philosophical rather than strictly empirical, modern physics approaches a comparable conclusion through the holographic principle, which posits that all information within a volume of space may be encoded on a two-dimensional boundary. Remarkably, each fragment of this boundary contains information sufficient to reconstruct the whole. Artists and composers intuitively understand this principle. Creativity is often experienced as interception rather than invention. Mozart, for instance, claimed that his melodies arrived fully formed in his mind, as if dictated by an external source. In a similar way, Wolfram's vision of the universe sees reality itself as a computation running continuously, with Akasha representing the overlap between computation and consciousness. Tom Campbell and consciousness as fundamental deal. Tom Campbell, a physicist and former NASA systems engineer, offers a complementary perspective in his model My Big Theory of Everything, My Big Toe. Unlike Wolfram, who places computation at the foundation of reality, Campbell posits that consciousness is primary, and the physical world is a simulation rendered by consciousness to facilitate growth and learning. In Campbell's framework, humans are avatars navigating a virtual reality designed to optimize learning and reduce entropy, information disorder analogous to thermodynamic entropy. Death, in this sense, is not final. It is simply logging out, while reincarnation is a continuation of the learning process under a new instance. Ethical behavior, compassion, and relationships are understood not as commandments, but as strategies that accelerate the growth of consciousness and the reduction of disorder. Where Wolfram provides the computational processor, Campbell provides the conscious user. Both perspectives are compatible. The same underlying patterns can be interpreted as computation by one lens and consciousness by the other. Where rule and consciousness meet. Wolfram and Campbell converge on a shared insight. Reality is structured, yet emergent, and complexity arises from simple principles, whether computational or experiential. Akasha serves as a conceptual bridge, a medium where the computational and the conscious intersect. Fractals illustrate this idea vividly. Zooming into a coastline or tree branch, the pattern repeats endlessly, reflecting self-similarity at all scales. Similarly, in holography, breaking a surface does not destroy the encoded information. It survives in each fragment. Physics and mysticism are not mutually exclusive. They are simply different ways of exploring the same underlying phenomenon. Machines composed of matter, computers, sensors, or AI cannot access the richness of this medium. Consciousness, immaterial and non-local, can attend to subtle patterns that material instruments cannot detect. True insight arises not from forcing answers from the universe, but from attuning attention to the gaps and patterns that exist between moments, between thoughts, between breaths, between the tick of a computational hypergraph. This gap corresponds to the 99.999% empty space within atoms, the quantum fluctuations in the vacuum, and the subtle substrate described by Akasha. Practical reflection, thinking, creativity, and mindfulness. Understanding reality as an interplay of computation, consciousness, and emergent structure offers practical guidance for human life. First, in thinking and problem solving, it suggests that clarity comes not from forcing solutions, but from observing patterns and allowing insight to emerge. The mind, like the universe, operates iteratively. Simple rules, repeated with attention, can generate complex outcomes. Second, for creativity, it affirms that inspiration is often interception rather than invention. By tuning attention, whether in writing, music, art, or science, we can access the field of ideas that exists beyond conventional linear thought. Just as Wolfram sees complex patterns arising from simple rules, the creative mind can discover richness from minimal gestures, a single note, a phrase, or a concept. Finally, in mindfulness and presence, the notion of Akasha as the medium between form and awareness encourages stillness and attunement. Observing the spaces between thoughts, the subtle moments in daily life, or the patterns underlying events allows for a deeper understanding of oneself and the world. Awareness is not about control. It is about participation in the unfolding process. Applied practically, these insights suggest a life of patience, attentive observation, and respectful engagement with complexity. By recognizing that everything, nature, consciousness, and human experience, emerges from simple principles interacting over time, we cultivate resilience, creativity, and a profound sense of connection. Conclusion: there is no hidden wizard, no divine architect pulling strings behind the curtain. Reality is a process, elegant, relentless, and awe-inspiring. Wolfram's hypergraph ticks. Campbell's consciousness observes. Akasha, in ancient terminology, describes the medium where computation and awareness intersect. Humans are not passive observers. We are functions within the computation, momentarily aware, capable of witnessing and participating in the unfolding of rules. We are both the player and the observer, reading the program even as it continuously writes us. This framework bridges science, philosophy, and spirituality. It allows us to see the universe as simultaneously code and experience, computation and consciousness, structure and dream. We inhabit the corridor of rulal space, attentive to the gaps, listening to the resonance, and participating in the creative unfolding of the cosmos. Tick. Learn to cook with confidence. A holiday cooking experience for teens and school leavers. Cooking is one of the most important life skills a young person can develop. We eat every day, and knowing how to prepare good food sets you up for independence, creativity, and lifelong well-being. In my holiday cooking classes, I go far beyond teaching recipes. I blend knife skills with the wonders of food science, the chemistry, biochemistry, and nutrition that shape every flavor, texture, and aroma. It's the practical, delicious side of the science you learn at school. My sessions are fully hands-on. You will feel the warmth rising from a pan, hear onions sizzling into sweetness, smell butter turning nutty and golden, and watch simple ingredients transform into something extraordinary. Cooking becomes a sensory adventure, not a chore. To ensure every student gets dedicated attention, I keep each class small, just 3 to 6 participants. We learn by doing. We taste constantly. We experiment with confidence, and we uncover why small changes in technique make big differences on the plate. Classes are held by appointment throughout the December school holidays. Each session gently builds confidence, skill, and curiosity as students work from raw ingredients to a finished dish they can proudly serve at home. And here's something parents love. My class fees are by donation. If your child walks away bored or unmoved, you pay nothing. But if your child returns home excited, inspired, and perhaps presents you with a classic French onion soup, richly caramelized and impossibly fragrant, then simply contribute what you think that experience is worth. If your child keeps pestering you to bring them back for more classes, well, you'll know you've got your money's worth. All proceeds help fund my ongoing eye treatments, so every contribution goes to good use. Students will also learn how to choose fresh ingredients and shop smart. Do give them some grocery money, because selecting produce confidently is just as important as cooking it well. If you're ready to turn curiosity into skill and skill into joy, I would love to welcome your teen into my kitchen. Parents are most welcome to sit in as chaperones or return at the end to savor their children's culinary creations.